Hello everyone, today we'll be presenting our project on API security, focusing on vulnerabilities and defenses in the modern web services. To start off, let's understand what an API actually is. An API, or Application Programming Interface, is a structured way for different software systems to communicate with each other. It acts as a bridge between a client, like a mobile app or web browser, and backend systems. So instead of directly accessing a database or internal logic, the client sends a request to the API, and the API returns a response. This communication usually happens over standard web protocols like HTTP. APIs are used everywhere in the modern software systems. In web application, they connect the front-end interface to the back-end services. In mobile apps, almost every action like logging in, loading content, or making a payment relies on an API. In cloud environment, microservices communicate with each other using APIs. And the APIs are also used to integrate third-party services like payment systems, maps, or authentication providers. So essentially, APIs are the backbone of how modern applications function. The most common type of API used today is called REST API. REST stands for Representational State Transfer. It uses standard HTTP methods to perform operations. For example, GET is used to retrieve data, POST is used to create data, PUT is used to update it, and DELETE is used to remove it. REST APIs are stateless, meaning each request contains all the information needed to process it. They also use structured URLs, like accessing a specific user through an endpoint such as /API/user/123. This standard approach makes REST APIs simple, scalable, and widely used. APIs typically exchange data using JSON, which stands for JavaScript Object Notation. It's a lightweight and human-readable format that uses key-value pairs to represent data. For example, a response might include user's ID, name, email in a structured format. While this makes data easy to work with, it also means APIs directly expose structured information. If not properly secured, this can lead to sensitive data being accessed or leaked.
Hello, everyone. In this section, I'll be talking about API attack surface and security risks. An API's attack surface is a total set of points where an attacker can try to enter or extract data from a system. APIs are uniquely dangerous because they are intentionally exposed. And here, I'll be talking about why APIs are an attractive target. And I have 4 main points. And the first point is direct access to data and logic. APIs don't just show data, they expose real operations, like creating users, fetching account details, and processing payments. Attackers aren't just reading information, they're triggering real actions. And the second point is scale of exposure. A single API can serve millions of clients, including mobile apps, partner services, internal tools. So a single weakness affects everyone at the same time. The third point is rapid development culture. APIs are often built quickly, and security gets overlooked. Old forgotten endpoints, called shadow APIs, remain publicly accessible long after they should have been retired. And the fourth and final point is automation friendly. Credential stuffing, enumeration attacks, and scraping are some of the ways attackers can automatically attack a poorly secured API by using scripts. And here, in this section, I'll be talking about how improper design creates vulnerabilities. The first of the 3 points is overexposure of endpoints. APIs sometimes expose more routes than needed. If an admin user's page exists and isn't locked down, anyone can find it and target it. The second point is no distinction between internal and external APIs. Internal APIs, meant only for company use, sometimes end up exposed to the whole internet due to misconfigured servers. And the final point is lack of versioning discipline. Old API versions get replaced but never shut down. They still work but don't get security updates, and attackers specifically look for those.
Hi, I'm Aaron. I'm talking about common API vulnerabilities, specifically based on the OWASP API Security Top 10 list made in 2023. So just going down the list of the most prominent ones, we have broken object level authorization, broken authentication, broken object property level authorization, unrestricted resource consumption, broken function level authorization, unrestricted access to sensitive business flows, server-side request forgery, security misconfiguration, improper inventory management, unsafe consumption of APIs is number 10. At the bottom, I have just kind of some special points through time. So like 2019 was a focus on like mass assignment injection attacks. 2023 was the OWASP update, which focuses more on business logic and SSRF. 2024 is integration of when AI is being integrated and attackers are now exploiting LLM backends. And then 2025 is more rise of the autonomous AI agents and MAAS fraud. So first, I'm just going to talk about some of the threats. Specifically, the number one threat is broken object level authorization. And this occurs when an API endpoint handles object identifiers without proper authorization checks. Attackers can just go in and change numerical or UUID parameters, and that can lead to unauthorized access to personal information or business information. Broken user authentication is the second largest threat, and this stems from incomplete or incorrect implementation of identity verification. Attackers are able to exploit weak passwords and the weak policies regarding those passwords, and these compromised authentication give attackers an easy way into the API ecosystems. And the third is the fourth threat is resource consumption, and this occurs when APIs do not enforce strict rate limiting or payload size restrictions. This makes the APIs vulnerable to denial of service attacks, and attackers are able to flood the API, and denial of service attacks attackers are able to flood the API with high frequency requests, which lead to the disruption of services.
Today I'm going to talk about the real-world API security incidents and how vulnerabilities in APIs have led to major data breaches. APIs are used everywhere in modern applications, and they often handle sensitive data and important system functions. Because of this, they become a major target for attackers. Even small mistakes in API design can lead to very large security problems. One major example is Facebook in 2018. Attackers exploited a vulnerability in the API related to access tokens. These tokens are used to keep users logged in. By stealing over 50 million tokens, attackers were able to take over the user's accounts without needing passwords. This is an example of broken authentication. Another example is the T-Mobile breach in 2023. In this case, an API exposed customer data because it didn't properly check whether users were authorized to access certain information. As a result, data from about 37 million users worldwide was leaked. This type of issue is called broken object level authorization. A third example is Peloton in 2021. Their API allowed anyone to access user profile data without proper authentication. This exposed personal data like age, location, and workout information. This shows how improper authorization and excessive data exposure can put users at risk. These examples show that APIs are a major attack surface. Most of these breaches happen because of weak authentication, missing authorization checks, or exposing too much data. The key takeaway is that even small API security flaws can lead to massive real-world consequences. That's why securing APIs is critical in modern software systems.
Mitigation strategies and best practices. Why API security matters. APIs can transfer sensitive personal data. If an API is not properly secured, back-end access to the system can be breached. Mitigation strategies to prevent attackers from breaching APIs include authentication and authorization, input validation and secure coding practices, rate limiting and API monitoring, gateways, and security. Authentication and authorization. Authentication is the API asking who the user is. The API keys will give a user a specific login token to verify their identity. And authorization is the system giving permissions to this user. This practice must be secure, elsewise an unauthorized user could get permissions that they otherwise could not have. Input validation and secure coding practices. Input validation is the API only accepting data from the user that is in an understandable format for the data to help prevent from buffer overflow attacks where a user could input an overwhelming amount of data into a system in order to breach it. Inputs put into the system by a user are not to be trusted until they are properly parsed through. Rate limiting and API monitoring. Rate limiting is the limit on how many requests a user can make in a given time. It cannot be too strict to inhibit the functionality of the system to the user. And then this goes in conjunction with API monitoring, where the API monitoring monitors if a user is using the API in a suspicious manner, such as in brute force attacks, where a user will repeatedly try passwords until eventually they could get one right, as you can see in this little photo. And gateways and security. The gateway is the centralized entry point between the user and the backend. And this access point sets up authentication and authorization, rate limiting, monitoring of user requests, and routing. It handles all the security functions and centralizes these responsibilities so that it's more easy to manage this security. All right, thank you.